Okay, so let's go through the next part of the joist problem. And what we have already calculated is here the F sub B, which is the demand side. And where we got to now look for the um, strength side, F sub B. But we also know that we need modifications on this. So we are going to need to have F sub B prime is what we're going to actually compare to little f sub B. So F sub B prime is the modified bending strength and in stresses. If you go into uh, table 4.3.1, so this is NDS table 4.3.1. Let me grab something here. No. All right, so NDS table 4.3.1. I'll call NDS the code and supplement the NDS supplement. All right, we go in there, we're going to find the table that shows us for a given type of loading. So in this case, we're looking at bending, which coefficients I need. And that is, we talked about this on the last lecture, CD times CM, then CT, CL, C sub F, C sub FU, C sub I, and C sub R. Okay, so lots of coefficients, and that's what you'll find in wood is that we're dealing with a lot of coefficients. So first, we can actually go ahead and get F sub B here. Okay, so we can look that up. If I go into supplement table 4A, I can look up the F sub B value for him for number 2. And I will get F sub B equals 850 psi. All right, so if you take a look here, our demand is 810. If I didn't have any modification factors or all these were 1 or greater, we would actually be in good shape. So this is, depending on all these different factors, is where you may or may not end up where you want to be with strength. So far so good. If this was lower than little f sub b, the demand, we'd still go take a look at this because some of these factors are over 1, but I would be less excited because I need to have overall those factors come above 1 to make this work. But you'd still go through the process because, like I said, there are some that are above 1. Okay, so let's just march through these. C sub D, actually I'm going to do this. C sub D is the load duration factor. All right, for this guy, you take, you go into page 11 of the NDS, which is table 2.3.2. Okay. I'm not going to do all these every time, but table 2.3.2, and you take the shortest and again, most of these factors just have to do with how the original testing was done, if it was a long time load, a short duration load. So the shortest duration of your loads controls. All right. So if you go into that table, you'll see load duration permanent, 10 years, 2 months, 7 days, etc. 10 minutes, right? So there's talking about a typical permanent load, of course, is a dead load. Snow load, they're talking about as a 2-month load. So of the loads we've got a dead load that's permanent, and we've got the occupational live load. And the occupational live load is in this particular table around 10 years. So this is the live load, and this would give us a factor of 0.9. This gives us a factor of 0.1. I'm just writing the dead load one down. We know that the live load is the shortest, so it controls. That actually gives us just 1, so that one already has gone to 1. you can just cross it out, but I'm going to leave it for this first example so we don't lose anything. So CD equals 1. All right, next one up is C sub m. Now we need to go into the supplement, and I'm going to go to mine. So in, oops, not in the supplement. Oops, sorry. Okay, in the supplement, it's going to be in Chapter 4, Reference Design Values. Okay, and in here, we've got values for CM and CR and CFU are all on this page. So it says table 4 adjustment factors. It's kind of, some of them are in tables, but that's basically what it is. So this is going to be in Chapter 4, Table 4A of the supplement. Supplement, Table 4A. And in here, C sub M, it's if you go to that page and pause the video if you need to, wet service factors. So where dimension lumber is used when moisture conditions will exceed 19% for an extended period of time. We are assuming in this one that we're at the 19% or below. Okay, so in this case, we assume CM is equal to 1 because those factors only have to be changed from 1 if that's the case. Okay, so 19% or lower. All right, so go take a look at that table. The next one is C sub T. Now we're going to go back over to the NDS. And yes, this is a little cumbersome. The same page that we were looking at the duration, and that's where the temperature factors are. So NDS table 2.3.3. This is page 11 of the NDS. Okay, that's the temperature factors. And so in here, we've got no high temperatures are specified for ours. So the table shows things for greater than 100 degrees. If it's less than or equal to 100 degrees, it's just a 1.0 factor. So C sub T is 1. No high temps. They didn't tell us anything, so we have to assume, since this is a problem given to us, that there are no special high temperature considerations. So this would be extended periods of time above 100 degrees, which is not typical. All right, so these go pretty quick, but you have to check each one of them. All right, so beam stability is C sub L. Oops. C sub L. This is the whole lateral bracing deal. And so if I go let's see, go into chapter, oops, sorry about that. Chapter 3 of the NDS. Oh, I'm sorry. No, we're looking at the, NDS beam stability is page 15, which I believe is in, it's in chapter 3. So we pull up chapter 3 of the NDS. Mine's loading a little slow. Sorry about that. All right, page 15 of here is where I've written this down. All right, so bending members general, and we talked about this beam stability factor in 3.3.3. So this is NDS section 3.3.3. And I will tell you that the hard copy I have of my NDS is tabbed with each of the factors, just with, so I can find C sub L or whatever pretty quickly in here. If you have the electronic copy, if you have the full-blown version, you could download it, or if you wanted to, you could just keep track of the page numbers so you can get to where you need to go for your homework problems. All right. Beam stability. These joists are laterally braced. And so we talked about this in some length the other day. Since they're laterally braced, then I get to use C equals 1. Why are they laterally braced? They're laterally braced by the deck. The plywood deck, basically. All right, so we get to use CL equals 1. Consistent here. Okay, now where are we? We've got CF is next. CF is a size factor. I just realized I didn't rotate my screen this time. Hopefully this still is reasonable for you to read. We'll find out. A size factor, if I go into the supplement in reference design values, which is chapter 4, I need to go to page 32, where they have size factors, and this is in table 4A, supplement table 4A. All right. And in that table, if I look at what I have a number 2 grade, and the width of these things were 8 inch wide, 2 inches thick. So width 8 inches wide, thick 2 inches. I get a size factor of 1.2. So I finally have one, and it's actually better. So this is making my situation better. So number 2, a 2 by 8 is what I go into that table with. Okay. All right, next, I am going to go ahead and change my screen around here. Sorry about that, and this will zoom in for a little bit. Let's do our C sub FU. And this is the flat use factor. This is also in supplement table 4A. Okay, if I look in there, it talks about flat use factors, width and depth. Okay, size adjustment factors are based on edge-wide use, so load applied to the narrow face. When it's used flat-wise, then you have to put one of these factors in place. So this is not applicable because we're not using flat use. When it's not applicable, it equals 1. Actually, why it's doing that. C sub FU equals 1. Okay, let you make sure you've got that copied down. Next, we'll move into C sub I and finally C sub R. So I'm going to go ahead and go to the next page of engineering paper here. We're getting there. C sub I. C sub I is on page, it's in the supplement. Let me grab the right one. So this is in the supplement in chapter 3, section properties. It's page 30 if you're looking at the page numbers. Okay, so this is table 1D of the supplement. Supplement, table 1D. We look in here, this is section properties of southern pine, structural glued laminate timber. We're not, oh wait, sorry. I'm in the wrong thing. Strike what I just said. I grabbed the wrong page. I say that doesn't sound right. We need to be in the actual NDS here. And I'm almost there, and then I'll get to this thing. All right, this is the incising factor. So ignore what I just did here. Erase. Okay, so C/I is incising. Sorry, I was reading the page number and didn't look at the... And we know that's the thing where you have the little lines. That's not applicable here. We don't have any incising. So that is also CI equals 1. I was looking at the wrong part. Okay, so if you go there and you do have incising, it'll go in and talk to you about it. You'll get the information from page 30 or section 4.3.8 of the NDS. Okay, let me write that down. So you have that in case you have one with incising. All right, next we have the repetitive member factor, C/R. Okay, and that is in page 30 of the NDS, which is where we just were. So same thing, which is 4.3.9. So just the next section of the NDS. And it says reference bending values shall be multiplied by the repetitive member factor 1.15 when they are used as joists, trusses, etc., which are in contact or not spaced more than 24 inches on center. Okay, and are not less than 3 in number. So we do meet this, okay? You can also look at page 32 of the supplement here. Where it goes in and it shows you the actual repetitive member factor, says the exact same thing of what I just said. So this is actually in two places. It's in table, also in table 4A. Supplement. Okay, so we use C/R equals 1.15 because we do have joists that meet the requirements that are in that paragraph. Right, there's more than 3 of them. They're spaced less than 2 feet apart. So I get, and there's joists. Okay. So that's just saying it's basically a redundancy type factor. If I had a single joist or the joist was really far from the next one, I don't have really any load sharing there, and so it's not going to get a redundancy. But if I have alternate load paths like this, I'm going to get a little bit, I get to bump up a little bit. So we're actually going to end up higher because we didn't have any that took the value down. So that's one thing. I started out showing you that if we lost much, we weren't going to be able to meet the demand. But in our case, what we're using actually bumped up. So if I go back now to f sub b prime, it's the 850 psi, which was the f sub b, times all these values. And I'm going to go ahead and just write the ones in here for the heck of it. It's not a bad practice to do, especially like when you're doing the PE, you can just kind of check them off and make sure you have everything, but you don't need to write all the ones down for me, as long as you show me you've looked at all of them. All right, so we're going to bump up by 1.2 and 1.15 here, and that's pretty significant. We'll get 1130 or 1173 psi, and that is the strength side. Okay, so this is what's provided. So F sub little b is 810, and that's less than F sub b prime, large F sub b. So, okay, bending. All right. So we got to the end of that joist for bending. That was 810. It's less than 1173. We had plenty of capacity, extra capacity here. Okay, I'm going to stop with this one, and then we're going to move on to the next piece.